All right, so in this section, we're just going to kind of do a brief overview of how we can visualize the complex numbers. We could think of each complex number really as a set of coordinates. It's got a real part and an imaginary part. So we take our real number line that we know and love. Here it is. It's the horizontal axis. And then we just take perpendicular to that an imaginary axis. So those are marked at J, 2J, 3J, and so on. Now each point, each complex number is a point on this plane. So 2 plus 3j is 2 on the real, positive 3j, there's that point. Every point on this plane corresponds to a complex number, and every complex number has a location on the plane. In this sense, the complex numbers, we say, are a two-dimensional vector space over the reals. And it's not really a big leap for us to see that because, given a point, I could draw this line starting at the origin and see that we have some magnitude and some direction, and we'll talk about that more in the next section. One way in which we can think about, or in which we get some insight into complex numbers by thinking of them as points on the plane, is that we can sort of add them graphically. Now, for me, when I add them graphically, I don't use this technique to find the sum. I kind of visualize where it is. I will still do like the techniques that we used in the last section to make sure that I have a precise result. But these complex numbers are vectors, and when we add vectors graphically, we add them tip to tail, and we can do the same thing with these complex numbers. So let's say I want to add these two, 5 minus 2j and negative 2 minus j. So first, I'm going to just plot these on the plane. 5 minus 2j, so positive 5 minus 2j, and negative 2 negative j, that's right here. And so here are these as vectors. Now if I want to add them tip to tail, let's say I start with the 5 minus 2j, I'm just going to take this vector here, and I'm just going to slide it down this way so that it starts at the end of the 5 minus 2j vector, and this spot where it ends, that's the sum right here. And it appears to be at 3 minus 3j. We can confirm by actually doing the addition the way we already know how from the last section. So this is 5 plus negative 2 plus negative 2j minus j, which is 3 minus 3j, which agrees. I have not assigned any exercises from this section. You could certainly take a look in the textbook. It's section 12.3, but it's kind of like exercises like this, like plot this point, draw where it looks like the sum ends up. We're going to find that this graphical or visual interpretation is really, I think, helpful in terms of it giving us some insight into what we expect to happen. And I want us to hold on to that, but I don't see a whole lot of value in just having you plot some points as exercises. In the next section, we're going to kind of bolster this idea of complex numbers as vectors.